Gravitation is the name given to a force of attraction between any two bodies in this universe. We know that we have got four types of forces: gravitational force, electromagnetic force, nuclear force, and weak force. The electromagnetic forces can be attractive as well as repulsive. Nuclear forces can be attractive as well as repulsive. Weak forces are always attractive, and the gravitational forces are always attractive. The gravitational forces are weakest of the four, but the most important of the four, because these gravitational forces hold this universe together. We will discuss about the universal law of gravitation. The universal law of gravitation was given by Isaac Newton based on the fact that he was sitting below an apple tree and an apple fell down towards the ground. Now, the universal law of gravitation states that if we are having two bodies, m1 and m2, placed r meters apart, this mass m2 exerts a force on m1 that is given by F12, and the mass m1 exerts a force on m2 that is given by F21. Let the unit vector from 1 to 2 be given as r12, and the unit vector from 2 to 1 be given as r21. The universal law of gravitation states that the force is directly proportional to the product of the masses, that is m1, m2, and the force is inversely proportional to the square of distance between the two bodies. Combining these two facts, F is directly proportional to m1, m2 divided by r square. Now, this is a proportionality sign. In order to remove the proportionality sign, we have to introduce a constant of proportionality. And that constant of proportionality, by the help of calculations of the force, has got a value, and it is given as gravitational constant G. So, F is equal to capital G m1, m2 divided by r square, where G is the universal gravitational constant, which has got the value of G is equal to 6.67 into 10 raised power minus 11 units is the value of G. It is all about the universal law of gravitation. We will try to define G. We know that F is G m1 m2 divided by r square. If we take m1 is equal to m2 is equal to 1 kgs each, and r is equal to 1 meter, in that case, putting the values of m1, m2 and r in this equation, we get F is equal to G into 1 divided by 1 square, that is equal to G. So we can say that the gravitational constant is numerically equal to the force between the two bodies of mass 1 kg each, separated by a distance of 1 meter. Listen closely. The gravitational constant is numerically equal to the force between the two bodies of mass 1 kg each, separated by a distance of 1 meter. It is the definition of G. So it is numerically equal to. Let us see the units of G. So G can be equal to Fr square divided by m1 and m2. Let us see the units and let us see the dimensions of G. The units are, so the force has got Newton unit, distance has got meter, and that is meter square, divided by mass has got kg, that is kg square. So the units of G are Newton meter square per kg square. Dimensions of G. So again, G is equal to Fr square divided by m1, m2. The force has got dimensions of ml t minus 2. The distance has got dimensions of L, that is L square. And the mass has got dimensions of m, that is m square, because it's a product of two masses. Simplifying it, it comes equal to m minus 1 L3 t minus 2. So the dimensional formula of gravitational constant is m minus 1 L3 t minus 2. Now, As already discussed, the value of G is 6.67 into 10 raised power minus 11. Earlier I said units, now the units are confirmed, that is Newton meter square per kg square. So the value of G is 6.67 into 10 raised power minus 11 Newton meter square per kg square. This is the value of gravitational constant.